Assalamualaikum warahmatullahi wabarakatuh. Today we would like to discuss about application of differentiation. First of all, I will introduce my group members. The first one, we have FIRDATUL ASYIKIN. Next, AMIRA SYAFIZA. The third one is SAZLIN NABILA. And the last one is me, HANAN. Me, ASYIKIN, AMIRA and SAZLIN are overwhelmed in all humbleness and gratefulness to acknowledge our debt to all those who have helped us to put this idea well above the level of simplicity and into something concrete. We would like to express our special thanks of gratitude to our lecturer, Madam Jasmani binti Bidik, who gave us the golden opportunity to do this wonderful project in creating a video presentation on the topic application of differentiation, which also helped us in doing a lot of research and came with a lot of ideas. We are really thankful to them. Any attempt at any level cannot be satisfactorily complete without the support and guidance from our parents and other friends. We would like to thank our parents who helped us a lot in gathering different information, collecting data, and guiding us from time to time in making this video, despite of their busy schedule.
At the end of this lesson, we're gonna know about the definition of differentiation, application of differentiation, definition of related rates, and problem solving about related rates. What is differentiation? Differentiation is a process of finding derivative or the rate change of a function to determine the maximum and minimum value of particular function. There's a few techniques to solve differentiation problems. For example, derivative of constant linear and power functions, derivative of sum and difference, product rule, and quotient rule. There's a few applications of differentiation that we can do. First one is related rates. Next, analysis of function 1, which is intervals of increasing and decreasing functions, and concavity and inflection points. Next is analysis of function 2, which is relative maxima and minima, and first and second derivative test. Next is maximum and minimum problems, and the last one is Rolle's theorem and mean value theorem.
2, 3.
What is related rates? Related rates is a problem that involves at least two changing quantities. The rate of change usually with respect to time. To compute the rate of change of one quantity in terms of the rate of change of another quantity that can be easily measured.
Now, we will go through the problems of related rates. The first problem statement is, an ice cube in the shape of cylinder is placed in the middle of the sun and melted at a constant rate of 3 cm cube per second. For the first question, find the surface area of the ice cube in terms of R. First, we are going to take the formula of area for a cylinder. A equals to 2 pi r square plus 2 pi r h. Now, we are going to replace the h with the height that is given, and that is r plus 3. Now, we're going to expand the 2 pi r and r plus 3, and we will get 2 pi r square plus 2 pi r square and 6 pi r. And then we are going to simplify, and we will get 4 pi r square and 6 pi r. For the next question, find the volume of the ice cube in terms of R. First, we are going to take the volume of the cylinder, and that is V equals to pi r square h, and then we're going to replace the h with the height given, and that is r plus 3, and then we're going to simplify, and we will get pi r cubed plus 3 pi r squared. For the next question, find the rate of change of the surface area of the ice cube when the radius is 6 cm. First, we need to find dA over dt. we need to differentiate the area that we have found in question A. And then we will get dA over dt equals to 8 pi r dr over dt plus 6 pi r over dt. Second, we need to find dV over dt. We need to differentiate the volume, and that is pi r cubed plus 3 pi r squared. And then we will get dV over dt equals to 3 pi r squared dr over dt plus 6 pi r dr over dt. Then we need to substitute negative 3 in dV over dt, and for the radius is 6. And then we need to make dr over dt the subject of the equation. And then we will get dr over dt equals to negative 1 over 38 pi. Last but not least, we need to substitute dr over dt and r into dA over dt. We got dA over dt is equal to negative 1 over 38 pi and r is equal to 6. So we need to substitute that in dA over dt. And last, we will get dA over dt equals to negative 14.0253. In conclusion, the area is decreasing at the rate of 14.0253 centimeters square per second.
Okay, now I'll proceed to the problem statement 2. A teapot with the shape of cone with a radius of 7 cm and 20 cm of the height is filled with the hot chocolate at a rate of 20 cm cube per second. How fast the tip of the water increasing or decreasing when there's already 12 cm height of hot chocolate in the teapot? Okay, now proceed to calculation. Step 1. Find R. R over 7 equal to H over 20. 20R equals 7H. R equal to 7H over 20. And final answer, R square equal to 29 over 400 H square. Step 2. Find volume water. V equal to 1 over 3 pi R power of 2H. V equal to 1 over 3 pi times 49 over 400 H square power of H. V equal to 1 over 3 pi times 49 over 400 H cube. V equal to 49 over 400 pi H cube. Step 3. Find dV over dt. Differentiate V equal to differentiate 49 over 400 pi H cube. dV over dt equal to 49 over 400 pi times 3H cube dH over dt. dV over dt equal to 49 over 400 H squared dH over dt. Last step, substitute dV over dt equal to 20 and H equal to 12 into dV over dt. 20 equal to 49 over 400 times 12 square dH over dt. 20 equal to 49 over 400 times 144 dH over dt. 20 equal to 441 over 25 dH over dt. dH over dt equal to 20 times 25 over 441. dH over dt equal to 500 over 441 or 1.138 cm per second. In conclusion, the hot chocolate is increasing at the rate of 500 over 441 cm per second.
End of the slide. From this discussion, we all know that the topic of related rates can be applied to our real life by using the formula and the concept of differentiation. This is the reference that we refer to. And that's all from us. Thank you so much for watching. Bye bye.